Problem 3. 5 rectangles A, B, C, D, E are arranged in a square shown below. These rectangles have dimensions 1 by 6, 2 by 4, 5 by 6, and 2 by 7, and 2 by 3 respectively. Which of the 5 triangles or rectangles in the shaded region is the dimensions of the shaded region below? So before you approach any question where you see like a very nuanced and not very general kind of question like probability, you always want to start by generalizing some sort of relationship within geometric figures. And to do this, you never start with numbers, you start with variables. Since we do not know what the side lengths must be, let's call them A, B, C, D, E, F, G, and H, right? In this case, what are the dimensions of my outer squares? I have A by H, I have a B by C, or let's go in order, right? We're going height by width, so have some consistency. So we have A by H, right? A is the width, H is the height. So let's keep it consistent. This is C by B, this would be E by D, this would be G by F, right? Then what is the pattern you conclude about this figure? Well, we know that this is a square, so all side lengths must equal. In this case, A plus B must equal, C plus D must equal. So let's write it out within this relationship. A and B sum together must equal. C and D sum together must equal. E and F sum together must equal. And lastly, G and H sum together must equal. Notice the very distinct pattern among the 4 given dimensions. So if we were to somehow draw out this relationship, then we would have solved the question. Well, if we have 1 by 6, 2 by 4, right, then we know that 6 and 2 must sum to 8. So there must be some quantity here that's 4. Well, I used a 1 and 6, 2 and 4. I don't have another term where the x is a 4. So 8 must not be that particular number that I'm looking for. Let's try another arrangement. If we have 2 by 4 and 5 by 6, well, that's a 4 and 5, which is 9. So there must be 6 and some 3. Well, I used up 2 and 4, 5 and 6, and I don't have a term where putting here will give me 9. So this must also be a failed case. Let's try another one. Let's try 5 by 6 and 2 by 7. Well, if I were to have, 2 by 7 and 5 by 6 used, then 6 and 2 must give 8. So 7 must combine with something with 1. And I see here that 1 and 6 has that pattern. So 1 can go here and 6 will go here. But that means this must have a 2. And then likewise, I have 2 by 4 or 2 by 3. Well, let's try both of them. If I have 2 by 4, then 6 and 2 would work, but look what happens to 4 and 5. They don't sum up to the same number. So it cannot be 2 by 4, it must be 2 by 3. If I do that, 2 by 3, 6 plus 2 is 8, and guess what? 3 plus 5 is 8. It satisfies the pattern we saw generally. So therefore, this possible arrangement must be the dimensions of the rectangles that border that inner square. In this case, we used up every single dimension except 2 by 4. So that dimension must be the dimension of the inner square. Therefore, our answer choice is answer choice B, since B corresponds with 2 by 4.